Yeah.
Thank you, Holmes. I think we're good.
Okay.
Thank you. Thank you so much. Take time for review the slides. Okay, good morning, everyone. Now let's get started. Like we just mentioned, today's lecture, we will have two key topics, array and merge statement. Firstly, about array. Array is a way for us to group a set of variables for the programming. After using an array to group a list of variables, we can then refer to the array to do later we can refer to the arrays that the array actually corresponds to a list of variables. So it will help us to simplify our programs, and we can use the array to do the programs very efficiently. And then for the merge statement, the merge statement is useful to combine different data sets. It will help us to get more comprehensive information for the list of patients if we merge a demographic data sets with medical conditional data sets. We will get to the examples later. Now, before talking about today's lecture, actually, I want to take the time for us to reflect what we have already learned. So in lecture 1, we learned about assessing data using PHAD import. And in lecture 2 and 3, we learned about some basic programming skill sets. Can anyone remind us what we have learned for lecture 2 and 3? Lecture 2, we learned about, I'm also digesting what we have learned. I still remember vividly what we learned in lecture 3, but what about lecture 2? If then statement. Yes, lecture 2 is very basic SAS programming. Think about it's keep statement, drop statement, and if then statement, conditional if statement. And then for lecture 3, we learned some more advanced programming skill sets. We learned about yes, we learned about if first of variable, last of variables, which help us to convert the data from visit level to patient level, which we mentioned is really, really important. And we have exercise about it. And we also learned about the retain statement, sum statement, which help us to retain the value across different rows. We also learned about lag statement. Oh, that's so far for the lecture 3. So now moving on for lecture 4, we will continue to talk about advanced data programming skill sets, the array and merge, which is not hard. And we will get through these topics. So firstly, why do we need array? The use of array help us to simplify the programming, the processing of data. And importantly, we use array so we can analyze repetitive data elements with minimal coding. Give you a very simple example in the coming programs. Suppose we have a file which we have a file which has 24 variables that indicate a temperature of each hour of the day. So each record in this data sets, we have 24 temperature variables. And these temperature variables are stored in a Fahrenheit. We want to convert them to a Celsius. We can do is what we have learned just in the lecture 2, where we learned the creating a new variables. We just need to create a new variables here. If you look at here, it's Celsius temperature 1 to until 24. And each one of them is just use the existing temperature variables and then multiply it by use a ratio. So we can create a list of new variables. But once we learn from today's lecture about array, what we can do alternatively is to first define existing variables using array statement, and then also create a new array. If you look at here, the existing variables, temperature 1 to 24, we created an array here. You just use this statement array and then temperature array. And we list these existing variables, temp1 to temp24. And we, at the same time, we also create an array that indicates these new variables we will create. And this array combined with the do loop, we can create this list of new variables. So array help us to define a list of variables at the same time. And of course, we will go to the SAS studio to look at some examples. Question here? Okay, it's a straightforward examples, and we will look at in coming slides to look at how we can have this array concept. And just more information, SAS array is a way of temporarily identify a group of variables. And this group of variables can provide us by defining them using array, we can further processing this list of variables just using the array statement. And one thing I want to emphasize here is that we have to define array in a data step, and then we can refer to this array in the same data steps. What I want trying to say is that we must identify array and also later use array in the same data set. We cannot identify array in a one data steps and then later use another data steps to call this array. We cannot do that. We have to do that in the same data steps. And array is not a new data structure. The array name is not a variable, and array do not define additional variables. Array is just a way for us to identify a group of existing variables or a group of new variables that we wanted to create in the same data steps. And usually when we have this array statement, we would use a different name rather than the variable's name. So we do not want array name to be exactly same as variable name. It's gonna cause some confusion. So we will use array, we will set a different name for the array. And this is more information about the basic array concept. Array statement define a variable so that they can be processed as a group. And each variable with an array, we can call it as an element. And once array is defined, which in the prior examples, we can use array name and its index number to reference to a specific variables within that array. We will look at examples later. And once array has been identified, we can then perform the task for this a series of related variables that using the array and index number to refer to that variable. I know it may sound a little bit abstract, but when we get to some examples, it will be more straightforward. And this slide is clearly demonstrate to us that how to define array and then how can we refer to these variables with an array. If we look at here, there are three big portions. First, in the data steps, we have start with array. We have to call the array. And then the next one is temperature underscore array. This is actually the array name. And there is a bracket 24. It means this array have 24 data elements. And then you list array elements, which is your existing variables, or maybe the variables you want to create it. It is temperature 1 until temperature 24. You can do this in this way, or you can just list it temperature 1, temperature 2, temperature 3. You can just type it each one of them. Clear? I want us to all remember this structure that help us to create array. So just start with array and then array name, and then the variables you want to be included in your array. Okay. It's very simple. And once your array has been defined within this data steps, now then you can process your data by calling this array. And I know I mentioned, but I just want to reiterate again that it's very necessary to define array within these data steps where you want the array to be referenced. So you have to define array and then use the array in the same data steps. And after talking about identify array or defining array, now we want to go to the next step is to reference your array, actually reference your data elements. Remember, in the temperature examples, we have array temperature, which is array name. Within that array, we have 24 data elements, right? They're temperature 1, temperature 2 until temperature 24. We can reference a particular temperature, maybe the 30th hour temperature of that day, using this array name along with the index number. So the temperature 30 can also be understood in the SAS data steps as a temperature underscore array bracket 30. So now this temperature 30 can be referenced using the array references. So when an array is defined, the SAS can create array references, and this array name along with index number combined as array references can be represented in this form: array name and the specific index number. With that, we can refer to a particular data element within that array. Okay. And this slide just clearly shows us for temperature 1, the array reference is just array name bracket 1. It's the first data element within that array. And then temperature 2 is the array name with the number 2 that refers to the variable temperature 2. Okay, and actually we have a list until temperature 24. So variable name and array references are interchangeable once we define this array. This is more information about what we have talked about. For this class right now, we focus on one-dimensional array. That we, if you look at here, that we have this temperature variable, and there is a temperature array references. So the first row and the second row, they are interchangeable. Now, I want to go to the SAS Studio to look at some examples. Let's all shift to SAS Studio. So let's start with the week 4. I will provide 3 examples about arrays. First, let's look at the data patient info. In this data, we have patient ID. We have several demographic characteristics. And you will notice that we have ELG 2701 until ELG 2017_12 7. This big data set is the data we can cut from claims data. So in claims data, the patient eligibility criteria is at monthly level. So month one, they have 1 or 0, indicating either one patient enrolled in this program. And then you will also have another, it's patient February, maybe the month two's eligibility criteria, and then month three eligibility criteria 0, 1. Here they have the 7 months. I think it's until eligibility 2017 07. So it can be 2017 July until 2017, 2017 January until 2017 July. So each monthly eligibility criteria indicator is one variables. We can, if we want to identify their eligibility during this period of time, what we can do, as what we have learned without array, is we can do it individually. We can summarize them individually. But once we have learned array, we can define this variable just using array statements. Before going into details, I also want to mention this data we have right now is the patient level data. So there is the 80 rows indicating 80 different patients, because each patient ID is one, so they are unique. It's just small data sets we cut from the claims data. Okay. Now, if we want to reference to these 7 eligibility criteria, we can define them using the array. Remember, array, and then this array name, and then the list of the variables. So if you look at here, we start with array, and then this is array name, it's called cake. You can call it eligibility, a group, or something like whatever you want to call it. This is just array name, we call it as a cake. And the 7 is the number of the variables within this array, right? Remember, we have the array name, and then there's a bracket, there's numbers. And then what about this ELG 2701 to ELG 2707? Those are the variables we have want to include in the array. And like we mentioned, you can either write it manually 01, ELG 2701, ELG 2702, or you can have them all together separated by the hyphen, because the structure for these variables are the same. Okay, can we run them? Let's just run them. There's something else I also want to share. After defining this array, we can use the cake. Remember, in the second part, when we talk about array, we also mentioned reference the array. How to reference the array is just with array name and index number. So this cake 4 is actually the 4th array value. We can create a new variables called 4th array value. That is corresponds to the 4th elements within this array. How about we start with create array first, and then go to, we can start just using let's just run it. Let's see the log. Logs looks good. The output data won't change much because we just define the array. But if we add these 2 newly created variables, if we added them there, we will create 2 new variables. if we go to see the log, there are 2 new variables created. Instead of 11 variables, now we have 30 variables. And if you look at output data, there are 2 variables we created, force array underscore array underscore value and 6 underscore array underscore value. And this force underscore array underscore value, it indicates to the force data elements within this array, which is ELG 2704, right? As we mentioned in the temperature example, temperature array bracket 04, it is actually temperature 4, right? This is you use array and the number to reference to these data elements within, the data elements within this array. Okay, I think this example is straightforward. Can we move on? Okay. The 1B. So after learning about this patient info data, we now have a little we have an exercise here that we can do together. Like we mentioned that each eligibility variable indicates a monthly eligibility indicator. Enrolled is 1, not enrolled is 0. What if we as outcome researcher, we want to identify for each patient how many months the patient has enrolled in this plan? We can do what we can do is to summarize them, right? Because each month the flag variable is either 1 or 0. 1 means enrolled, 0 means not enrolled. So we can summarize them. If we summarize it, we get 3, it means that patient has enrolled in 3 months. Correct? That's the easiest way we can do. Is that clear? Okay. So we can just summarize it. Let's just summarize it. So if we summarize it, we just create a new variable, which is by summarizing the eligibility month 1 to eligibility month 7. And the first patient, they have been enrolled in all the 7 months. The eligibility at the summary is 7. And the second patient, they have been enrolled in 6 months. Total of 6 months. This is a way we can do. Another way that we can do is that I want us to learn from today's lecture is to create an array. We can create an array called cake. The array name is called cake. And this array is from, this array has all the 7 variables within this array. And we can now then use a do loop. Firstly, we have to set the total months eligibility to 0. And then we use a do loop. Do 1 equals I to 7. If take I equals 1, actually this reference to either one of these eligibility criteria variables. If any one of them equals 1, then eligibility equals eligibility plus 1. And then we end this do loop, and then there's a wrong statement.
Line 46.
Okay.
Then after them, so is it eligibility equals 1 or eligibility plus 1?
eligibility will +1. So here's how
But
it's,
so, okay, my question is, so we don't need to specify eligibility equals to eligibility +1.
no, we don't need to do that. It's the sum statement. It means eligibility equals eligibility +1. But you can use the variable +1. And what I understood here is, for example, for the first observation, we have 7, actually for each observation, we have 7 variables. So they will start with cake 1. They will start, at first, all the eligibility is set as 0. But within this do loop, first, if the cake 1 equals 1, the first eligibility is 1, and then this eligibility equals the initial value 0 plus 1. And then they would move to, that's how I think, everyone. This is how I think. I just gave 3 observations here. Can anyone reminds me what are the for the first observation, what is eligibility 1, 2, 3? Just the flag variables. Second,
Sorry,
what are the ID1 eligibility 1, 2, 7
should be all.
within this data sets?
All one.
All is 1. Okay. So first method is really straightforward. I don't think anyone will need more discussion. It's just this eligibility criteria is summing all these variables, right? And the second method we're gonna use is we have a do loop. First, we identify this array. So all these variables gonna be called within this array. This array name is called cake. There's an array created for these 7 variables. And before this do loop, this eligibility criteria is set as 0. This is row 44. We all know this initial value is 0. And before going to next step, Sai, can you remind me the observation 2? What is the flag variable for?
Except for 6, everything was everything is 1.
Thank you. And what about row 3?
Everything's 1.
Everything's 1. Okay, sure. Okay, now we understood row 44, right? The initial value is 0. Okay, we got the coding for row 44. And then starting from this do loop, what does this mean? Do I to 7. It means that first start with I equals 1. I equals 1. If take 1 equals 1, the eligibility plus 1. So the SAS will read this first, take 1 first. For this first observation, the take 1 is the eligibility 1 equals 1. This one then will plus 1. Okay, this initial value plus 1. And then for the first observation, SAS will read the take 2, which is eligibility variable 2, right? This is also 1. They will continue at 1. Sorry. Clear? And then they will move along with this first observation, take bracket 3, which is eligibility month 3. They will continue to add 1. Then they will finish because I choose 7, so they will finish for observation 1 is eligibility 1 corresponding to cake 1 until cake 7, which is eligibility 7. Does it make more sense to everyone? Okay, make more sense for everyone. Okay, good. And then because it's only I to 7, and they would end after you have read for for example, first observation to read from cake 1 to cake 7, then they will end this do loop. So this is another way that we can count the total months of eligibility just by using this do loop. Okay. I would say this we will look at example in exercise 3. Actually, it will be more and more commonly used. For this monthly eligibility, I'm okay if you use do loop or you just use this sum statement. Actually, I use sum statement, but for exercise 3, we will need to use do loop, and we will get to that quickly. And exercise 2 is actually solving the same problem we have. Exercise 2 is also trying to accounting for the total number of the monthly eligibility. What they are doing right now is they create account eligibility equals 0. And they use a do loop. While this eligibility equals 1, they would add this this count eligibility to this variable. I think the logic is a little similar to what we have learned for this exercise 1B coding.
It's different, I think so,
Okay.
because once we hit 0, it'll stop counting.
While 0 equals 1.
Only when it's 1, it keeps adding. If it hits 0, it stops counting. I think that's the logic there.
Okay, let's see. Let's run it. Let's run whether the result.
It's written in the green, I think 60.
Okay.
It's written in the green. Loop stops running in each row as soon as eligibility
As soon
turns.
as eligibility, while eligibility equals 1. Okay. How about we just run it to see whether these two results are similar?
Because that is continuous enrollment. But
Mhm.
for the sum, for the last one, it is just adding up the number of months that they are. This is continuous, so that's why one you stop, then the do stop. Because while eligibility equals, it will stop once it reaches any column.
I agree. So the first one is just a summary of all these eligibility, and the second one is only while that eligibility equals one. If in the scenario that they have one, but 0, 0, 0, 1, they won't count this last one. They would only count while eligibility equals 1. So they will only count they have consecutive 1. So this exercise 2, yes, Cyan and Ivy. Exercise 2, this coding is more strict because they would only adding up that the eligibility months criteria, which is 1. Actually, they must be consecutive 1. Okay, let's I'm gonna trying to add them together into one code so you can see. So for example, everyone, the first observation, the eligibility and count eligibility is the same because they are 7, I mean, regardless. But the second one, the eligibility is 6, which we just adding them together, there's a 6. But for the count underscore eligibility, they only adding the first 5 because this one, the Y eligibility equals 1 is not satisfied. So they won't having this one. They're gonna just stop the first at the first of 5. So they the continuous eligibility, there's a gap here, they won't consider the following. And then the third observation is also 7. Thank you, Ivy, for pointing this out. Is that clear to everyone?
Yeah, so let me just share the light on this panel.
Okay.
Maybe it can clarify things. So the idea is the I counter, what it does is it counts it row by row,
Yes.
right?
Yeah.
So
And variable by variable.
yes.
Okay. Yeah.
Yes. So basically in the background, what it does is it's looking at each row that's representative of each variable, and then it's checking to see if it's either a 1 or a 0. So there is a latent variable that we created, which is the continuous underscore eligibility equals to 0. It has been retained there, although it's not visible. So each time the count variable sees, for example, if we have 7 of those columns right there. So if it starts from the first column and it sees the 1, that's one that it counts will be reflected in the latent continuous underscore eligibility of 0. That will change to 1.
Yes. This
then
one.
it will move to the next column.
Yeah.
If it sees another 1 there, it will reflect in the backdrop again.
Yeah.
That one will become 2.
Yeah.
And then it keeps taking it back to that latent variable until it gets to a point where either the entire argument is satisfied or violated.
Yeah.
At that point, it stops. So wherever it stops, whatever is reflected in that latent variable is what will now reflect in the actual variable.
In the new variable, yeah.
Yeah.
That's correct, Ben. And what is new to everyone, and including me, is count eligibility. Adding the while statement, they would only adding up while this cake array is 1. But if the next one is 0, they're gonna stop it. They won't continue adding up. So this continuous eligibility is something new for everyone. by adding this while statement, they would only counting consecutive one. So if you notice the count eligibility is smaller than eligibility. Okay, so it's clear to everyone. Okay, thank you, Ivy. Do you guys want to have a little break or we can continue? Continue? Okay, let's continue because at 1 there is a comprehensive exam. So let's continue. So I can have maybe we can finish class maybe 10, 15 minutes because at 1 p.m. your senior gonna have comprehensive. But feel free if you want some break, you can. Let's continue. When we finish all the array in the SAS student, we can have a little break. Okay. An alternative way that we can do is we can create two new flag variable. One is disenrollment flag equals 0 or count eligibility 2 equals 0. We need to have this array statement here because we mentioned the array statement must be defined if we want to use it. So we can have here.
The example is to explain
Mm-hmm.
how to do this without an array.
Okay. Yeah. That's correct. Yeah. Just a simple do loop. If eligibility equals 1. No, because I'll try to do the same thing above. You want this. So we create array, and there are two flag variables. If eligibility equals 1, disenrollment flag equals 0, and count equals. I'm not sure about this disenrollment flag variable.
We can tell me how many is like zeros
Uh-huh.
are in that. Are between eligibility 1, variable 3 eligibility 7.
Okay, so we have this. Thank you, NK. So we have this array here, and then there's a two variables, disenroll flag and conf eligibility. They are all set as 0. Disenroll flag and conf. If eligibility equals 1, the first row, first observation, first row eligibility equals 1, disenroll equals 0. I will try to understand it.
This enroll meaning for like, if for example, I do to the month number 6 will have a December flag on it.
Disenroll flag as 0.
As 1.
Oh,
When
because
it reached the
Okay.
month 6 for
Uh-huh.
ID2,
Mhm.
the disenrollment flag will be 1. Because if
Yeah, okay, yes,
Yeah,
yes. If-
So-
yes. So
so when it run the 7 times,
mhm.
it won't satisfy the first condition. Because the first condition
Yeah.
is this enrollment flag have to be 0.
Yes. Yes.
So it won't add up anymore. For the 7 times this loop.
Okay, okay. So just to repeat what you mentioned. Do I 1 to 7 eligibility equals 1 first, for example, let's look at the second observation. Because there's a 0 here. Eligibility equals 1, disenroll equals 0. Okay. Eligibility equals 1 and disenroll equals, because disenroll initial value is 0. So they will continue to adding up. Until that they reach eligibility equals 0, then disenroll is 1. They won't, okay, it's yeah, it's good. Let me repeat for those that we may need more time to understand. This coding here, they created 2 new variables, disenroll and cohort eligibility. Those are all set up as a 0. The difference is the disenroll is a flag variable that can flag if their enrollment eligibility flag variable for that month is 0. This disenrolled flag variable will set as 1. So this do loop, the first this do loop is if eligibility equals 1 and disenroll is 0, for example here, they will add up to this newly created variable, count eligibility 2. But until the 6th month, this flag variable is 0, this disenroll eligibility will become 1. That this, in that sense, this if condition are not met. And for this criteria, they are also counting the consecutive 1, which is a continuous eligibility.
The reason that makes the first if statement make sense is the second if statement.
You mean this first if statement makes sense, right?
No, the only thing that makes that first if statement makes sense is the second if statement. Without the second if statement, the first if statement doesn't make any sense.
No,
It is because the second if statement is dependent. I mean, the first if statement is dependent on. I mean, the variable disenroll on the flag for it to be completely populated is dependent on both if statements.
I would I agree with you partially. I would add to what you mentioned is that if we do not have the second if statement,
Yeah.
they will become just as what we have doing for the first coding, summarizing eligibility equals 1. Because everyone, the disenrollment flag does not make sense. The disenrollment flag always 0. Regardless, they won't have, if we do not have this criteria, we do not have this kind of stopping criteria, then the count eligibility 2 is the same as we summarize all the number 1.
I mean, the disenroll on the flag variable is a new variable we're creating, right? And it's just the only reason why it is logical is it is switching from 0 to 1. And then it's only making sense because we are tying it with the count variable that is counting the count. I mean, we are tying it with the counts that the count variable is making. Do you understand what I'm saying? Like for the disenroll flag on the flag to be 1, now it depends on what the elite into bracket I gives you. It has to give you 0 for disenroll on the flag to be 1. Without elite into bracket I being 0, disenroll on the flag can never be 1. Do you understand what I'm saying? Yeah.
Yes.
So
That's
so if disenroll on the flag can never be 1, and disenroll on the flag depends on what elite into bracket I is counting. And then the first statement is a Boolean logic that combines only when elite into bracket I is 1 and disenroll underscore flag, which a new variable will be created is 0. There's no way we can have a disenroll underscore flag variable that has a value of 1. The only thing we might be able to have is a zero underscore flag variable that has 0 and missing values.
Yes, that's the reason why we have the second if statement.
So the first if statement cannot stand alone. It has to switch for it to be able to get the cons underscore h2. For that cons underscore 2 equals cons underscore h2 plus 1 to make sense. Those
Because
two if statements have to.
it will be meaningless that if we do not have the second if, because all this in-row flag will be considered as the initial value, so won't make any meaningful impact.
Yeah.
So we need a second one just to so that the count statement can stop at the time when this one of the cake equals 0. One of the element of the cake array equals 0. Now, I know we have talked about exercise in the one. Now, I really want to draw our attention here for the exercise 3. This exercise, we all need to learn that one. It will help you to be successful in, of course, there are a lot of skills that you need to be successful in Dr. Bhattacharya's class, but this one, he will definitely request you will definitely have that kind of exercise. So I want to just quickly pause here, maybe just for a minute, for you just to understand this coding first before I talk about it, this position array. Okay, everyone. Now, let's first look at the the data we have from the claims data. This is the data we're gonna use for the analysis. Now, let me first talk about this data. This data is the drug prescription data. We can consider as a pharmacy claims data. So each patient, if you look at here, ban ID 1, its prescription fill date is February 2017, February 19, 2017. This is the day the patient has this prescription. And this prescription has a days of supply 30. And each patient can have multiple prescription records. This is a simple pharmacy claims data we have. We focus on several variables here. We focus on the fill date is when the prescription has been filled. We also focus on days of supply, is how long the prescription will last. The fill date, of course, is the date variables. So now the question here I would like us to first answer is first, can we identify all the prescription claims that a patient has filled before March 2017? Before March 31st, 2017. So we can just identify the first quarter's prescription claims. We just need to use will the prescription fill date less than March 31st, 2017. Okay. Now, the second question I want to ask is, let's just run the first code first. If you notice here, before that we have so the quarter one, we only obtained 40 observations, right? There are how many before? $82 before, so only about 40 claims were kept. They are before the March 31st, 2017. For example, if you look at it here, for patient ID 1, only the first 2 observations will be kept because others, they are happening after the March 31st, 2017. Okay. Now, the second question I want to ask is, after we identify all the patient observations in the first quarter, I want to ask, what are the total numbers of days of supply for this patient during the first quarter? Okay, we already have, let's look at here. We have this patient pharmacy prescription records here, right? We identify all of them before March 31st. So these 3 are gonna be removed, right? Because those are April. And then, for example, for patient 1, we have 2 records for him or her, February and March, right? I want to ask, what are the total days of supply for this patient? How can we do that? One way we can do, which is a little bit, I would say, we will use array, and let's go into detail about one of them. So I want to first draw this patient's prescription fill. For example, this is January, this is February, this is March. And March 90th, 2017 may be here. And this prescription lasts for 30 days, right? This is, February. I want you all to draw this diagram, if you can, in a piece of paper. February 19th, 2017, right? It's about February 19th, February 19th, 27th, in the same year. And this prescription lasts 30 days. So it's going to be 30 days like this. And the second claim for this patient is March 19th, which is like this. And 30. Easiest way you can do just sum all the days of supply, but this is not a precise way because these patients, I don't have patient, but a patient can have the first claims here and another claim can be before, so how to say, the patient can have a failed for another prescription even before the first prescription was finished. So they can have one claim here, another claims here. So they can have a claim overlap. So only adding this together will not be precise. We need to use position array. So each position can indicate whether just patient have a claim, yes or no. So what we will do is we will create a data structure like the calendar, like day 1, day 2, day 3, day 4. And in order to do that, we need to have a record for each patient, its first day and last day. The first day, it means that the field day, how many days passed since the how many days passed between this January 1st, 2017 for this patient's prescription. So if you look at here, if we get the prescription minus the January 1st, 2017, it is the time between the prescription field date and the since the January 1st, 2017. So for the first patient, it is this time. So the January 1st is the initial date, right? February 2017 minus January 1st is time. The date, times measured in days of the patient's current field date since the January 1st. And the second observation for these patients, it is the March 19 minus January 1st is this time, right? So each patient, we can create this, we can create these variables. It is the first day, it is the time passed since the January 1st until this current field date. Then we create a new variable for this patient. We can call it the first day. Okay. At this time, this data structure is still like this, but there's a first day variable created. And for the first patient, it is what is the field day minus January 1st, 2017 plus 1. This is the first position. Or we call it position, I think. We call it first position for this prescription. If I calculate it, it should be like 48 maybe for first patient. And we also have a last day. The last day is the first day plus the days of supply. So if you look at this picture, the first day is the first position that the patient has the prescription since January 1st. And then last day is the first day plus the days of supply. It's the last position where a patient has this this medication. So last day is the field day plus days of supply. Plus days of supply. So we have a first position and the last position. Is that clear about these two new variables we created, first day and last day? First day equals the field day. Just look at this picture. I hope like the first patient is February 19th, 2017. This is January, this is February, and this is March. And this is where they have this prescription. we can just run it and it will become clear. Oh. Just run it. If you look at here, the first patient's field day is February 19th. And first day is 15th. So February 19th minus the January 1st, 2017 plus 1. The first position is 15 days. You can consider January 1st as the day 1, and then January 2nd is day 2. And the first prescription day for this patient is February 19th, which is day 15th. Okay. And the last day is first day plus days of supplies, 8 days 18th. So if we consider this position, either 1 until 365 during this year, it's a way for us to calculate the positions. So that the field day will be converted into a position in a yearly basis. This is the first step. We converted the date in a position on a yearly basis, starting from January 1st, 2017. Okay? Okay.
So can you take out the second row?
Second row, sure. So second row, the patient's first field day is March 19th, 2017. So on a position level, it will be, February on a position level, it is day 78. So first month, 30 days, roughly. Month 1, 30 days, month 2, 30 days, and then it's March 19th. So it's day 78 on a position level. So the first step for us is to convert the field day into a position level on a yearly basis. Position can be on the largest position can be what? Because we only have the first records. First quarter of prescription. The maximum position we can have March 31st. Yeah, March 31st, exactly. It's about maybe 90 days or 91, the largest position we can have as the first day, because we only kept the first quarter medication field, right? So they are all less than 90. So clear, we all now understand first day, last day's position variables. And each one, the last day is first day plus days of supply. It means the last position that the patient has this medication in hand. Okay. Now, after doing that, the next step is to create an array. So we create an array, and this time, this array is day 1. If you look at here, this is the data structure we have now. Now we're gonna create an array. We can call this array day 1 until day 90. So there are 90 positions we wanted to calculate for this patient. So this array is from day 1, day 2, and day 90. There's an array here. And this array is the variables we wanted to create, because we wanted to evaluate whether each day the patient has this medication, yes or no. So this array day 1 to day 90, each one of them is a flag variables. Okay, then we use a do loop. Do I equals 1 to 90. If this I is between the first day and the last day, then this position array equals 1. Paying attention, this position array I actually indicate one of them. So there is this do loop can help us to understand whether each day the patient has medication, yes or no. If this is actually intermediate variables or just counter variables, however you want to call it, or index variables. This is i's 1 to 90. For example, if I equals 1, if 1 is between first day and last day, then the position 1, which corresponds to the day 1 is 1, but day 1 is 0, right? Because we know for the first record, the first day is about is, if you look at here, is February, it's about like 50 days, position 50, right? So in this first patient, this day 1 is 0. We can just quickly run it. You will get to know when you look at the ideal data structure when you run it. So if you look at this patient, the first day is day 50, position 50, because the first prescription is February 19th, 2017. And it means that the day 1 is 0, all the day 2 is, all missing only until day 50. I did not select nothing. Only until day 50, this flag variable, or we can call it this array variables, will become 1. Because I must be larger than the position for the position for the field day, smaller than position for the last day, which first day or last day is the positions. So there are basically 2 steps. First step is to have positions for the starting and ending of the prescription. The second step is to have these counter variables within these do loops. And if you look at the second patient, anyone can remind me what day the patient will have 1 for the medication? Starting day, which is 69, day 69, that is March 19th, 2017, right? That's the position for this prescription. Pause here if any question. You can understand 3 patients first. If you understand ID 1 to ID 3, or maybe at least 3 patients, it will give you.
Sorry, so why do you need number of variables labeled as day stop at 24?
Can you repeat which patient?
Okay, so when you run the code, after the
Just
last
select to show them on your left box. Just select to show all. Select all to show them.
Oh.
Just hidden. Select all. That's it.
okay, it's more than 24.
Yeah.
Yeah, there are 90
You can
days.
see on the top there'll be 96, I think so.
Mhm. Because by default, they can only show part of the variables because there are too many variables.
Okay, so other question is on days that are missing, right? And then those are the days that are reflective that the patient didn't have the drug, right?
Yes.
Okay. While the days that have one,
Yeah.
it's indicates that the patient had the drug.
Correct. Correct.
Okay.
Correct.
So how does this code here where it says if I is greater than or equal to the first day
Mhm.
and I is less than or equal to the last day translates to whether the patient has the drug or not?
So first day, last day is the position. It is the position that we created. Look at here. This position is 50, right? February is 50, and this position is like 80, is the end date. If the I is between this range, means the patient has this medication at hand, right? Position 50, position 80. Then I equals 1. But others, either I is less than this or I is greater than this, then the I is missing. Only if I is between the first day and last day, which is the first position and the last position on a regular 365 days level, then we consider patient has medication, which it means day 1, day 2, this array element equals 1.
So just the range and then you just spread it out and then populate it with one.
Yes,
within the range.
yes.
Sure.
Mhm. Just to reiterate what Ben asked, if we look at here, we can also look at patient ID2, the first drug. The prescription date for this patient is February 26th. The first day is 57 days. And it means day 1 to day 56 are all 0, only until day 57. The patient is patient ID2. Okay. The first day 57. The day 57 is 1. ID2.
So we just want a visual representation of it because we already assumed that the first day within the 90-day period is the 1st of January, right?
Yes, yes. We want on a yearly level. So we want it on a yearly level.
Yes.
So we create a starting date since January 1st.
Yeah, what I'm saying is we just want the spreadsheets to visualize it because we can already see if we assume that the first day within a 90-day period is 1st of January.
Yeah.
And then the first day the patients processed the drug is maybe day 15. So we know that it's day 15
Yeah,
from the first day.
exactly.
So we just want a spreadsheet
Yeah.
of it.
Yes. Okay. Okay, good. Well, you can have everything all together into one set of code, which we have shown here. Just put, creation of the first day, last day position, and also the due within one data steps. That's also what you can do. Now, I want to proceed with merge statements. Do we need a 10 minutes break or? I'm sorry, do we need? Or do you guys want to continue? Need a break? Okay, I'm gonna pause this video or everything. We can resume in 10 minutes or 50 minutes? 10 minutes? Okay, let's resume 11:45. Is that okay, everyone? I'm gonna stop the sharing and the video thing.